Concept number 43, areas of polygons. This first one, you got to be really careful with this trapezoid, because a lot of people look at this little segment over here that's 5 and assume that this little segment over here is also 5. But if we look at the triangle real close that's not drawn to scale, it says it's a 45, 45, 90. So it's really not drawn to scale. Because we know in 45, 45, 90 is that the legs are supposed to be congruent. So this side that's 9 should be the same distance as this side that's 9. So that's obviously not drawn to scale. But so we have to be careful with that. How long is this little segment between the dashed lines down here? 8. We can get that from the top, right? So the whole bottom base is how long? 22. So we remember the formula for the area of a trapezoid is sum of the, it's 1/2 times the sum of the bases. We got 8 and 22 times the height, which is 9. So we have 1/2 of 30 times 9, or 15 times 9, which should come out to 135 square centimeters. Then we had number 3, find the area of the rhombus. We know to find the area of a rhombus, we need to find the diagonals, because the area of a rhombus is half the product of the diagonals. So on this horizontal diagonal, if this little segment's 3, this other little segment's 3. If we look at the diagram in the triangle here, we've got a 30, 60, 90. So we know the short leg is 3, so the long leg should be √3 times that. So the area is 1/2 diagonal 1 times diagonal 2. Diagonal 1 is 6 long, so we have 1/2 times 6. If this segment's 3√3, this other segment down here is 3√3. If we add those together, we get 6√3. 1/2 of 6 is 3 times 6 is 18, so 18√3 would be an exact answer. If we put that in a calculator and round it off, it's about 31.18, or some of you guys said 31.2. That'll work. Questions or comments? Concept 44, areas of regular polygons. So these are regular. We got to find the area of a regular hexagon. They give us the apothem, they give us the side, and tell us around the nearest tenth. So what's that formula for the area of a regular hexagon or regular polygon? Sure. Area equals 1/2 apothem times perimeter. In this case, it's 1/2 times 9.5 times, how many sides does a hexagon have? 6 times 11 is 66. So that comes out to what? 313.5 square meters. Any questions on that one? Alright, number 5 was more difficult because they just gave us the side length and told us that we had a regular hexagon. Didn't give us the apothem, so we had to figure that out. So let's look at one section of the hexagon. We know that there would be 6 of these going all the way around, so that the angle here would be 60 degrees, 360 divided by 6. We know that one side of that thing is 6. The apothem's this distance right here. If we can find that, we're home free. If we drop that perpendicular, we're going to cut that angle in half, so that would be 30 degrees. We're also going to cut this side in half, that would be 3. The apothem then, in a 30, 60, 90, is the, in this case, is the long leg. The short leg is 3, so the long leg, the apothem, is going to be 3√3. So if we plug everything up in the formula here, area equals 1/2 times the apothem, 3√3, times the perimeter, which is 36. We should get, let's see, 1/2 times 3√3 times 36. Throw that in a calculator because they want it to the nearest tenth. We get 93.5 square centimeters. Any questions or discussions on that one? Concept 45 is about perimeters and areas of similar polygons. On number 6, the directions got cut out. I told you that the directions say that these are similar figures, and they want to know the ratio of the perimeters and the ratio of the areas of the similar polygons. Well, let's just take these two sides. Let's take 28 over 20. There's a ratio of the perimeters, right? But we need to reduce that down. What goes into 28 and into 20? 4, 7, and 5. So that would be the ratio of the perimeters. How do we find the ratio of the areas then? all we have to do is square this. So if we square 7/5, we get 49/25. Yeah, that's all we had to do. Number 7 is the same way. We're just going to take the two similar figures. We've got 24 over 42, what goes into both numbers. Let's start with 2. 12 and 21, what goes into both numbers? 4 goes in there, 3 and 7. So that's our perimeter. It's the ratio of the perimeter. So it should be 4 and 7 then, right? Ratio of perimeter. And then the ratio of the area would be what? Yep. 1649. So just square that perimeter ratio and we're done. Questions there? Concept 46 wanted us to use trig to find area. So we got to find the area of a pentagon with a side 8 meters. So on this one, I just said, okay, here's one of my sections of my pentagon. It's got 8 meters on the side. I need this apothem that's through here, so I need to find the angle here. Yeah, if I take 360 and divide by 5, I get 72. If I drop the perpendicular, it's going to cut the 72 in half. It's going to cut the base in half. It's going to be 4 meters there. The 72 is going to be 36. And now I've got to use trig, which is what they want us to do anyway, to find the apothem. So if we pull out the tangent ratio, we know that the tangent of 36 degrees is equal to 4 over A, the apothem. Therefore, A equals 4 divided by tangent of 36 degrees. And the formula, remember, is area equals 1/2 the apothem, which is 4 over tangent 36, times the perimeter, and there's 5 sides times 8 per side, should be 40. So if we throw that in a calculator, we should get real close to 110.1 square meters. Any questions there? All right, this last one's a square with a radius of 16. When I scored this, I looked at you guys' papers and you weren't drawing the radius in the right place. You're drawing the radius where the apothem goes. The radius goes from the center out in a polygon out to the vertice. So it goes out there. That's what's 16. So if that's 16, how far is it all the way across here? 32. Why would I want to know that? Because the square is also a rhombus. Well, you can do it different ways, but a square is a rhombus, and the area for a rhombus, remember when we did that on the previous problem? It's 1/2 diagonal 1 times diagonal 2. The diagonals are both 32, so it's 1/2 times 32 times 32, which is 512. And in this case, it's square meters. That's the way I did it. But like you said, you can cut it up into triangles and go that way, but then you're going to be finding other sides if you do that. But if you know your 45, 45, 90s, you're good to go.